Hey, hello students. This is the video I'm making for this is Algebra 2 Unit 4 and Lesson 1. So the lesson is let's check the learning target. The learning target is about if I can answer. This is the main thing. I understand how to calculate values that are changing exponentially. Let's see what does this means. The output changes exponentially. So if you see, the tasks are being done in the classroom. So my job is to do the practice problem. But before that, I will just walk through just 1 minute of what in this lesson what I'm supposed to know uh, is here. So I just an example. This is about the population growing about days since the population is measured. Okay? And you can see in the beginning, what does this zero means? In the beginning, let's see in the one city in Arizona, the population was 10,000. And then the next year, let's see, in 1 year, the population is says multiplied by 2. So you can see there's a multiplication, is 2 is multiplied. Then the next one is 10,000 times 2 square. So what does that mean is basically, uh, so what does that mean is from this step to this step, you're multiplying by a factor, right? So I'll just write this is 10,000 times 2, right? And then the next one is you're multiplying from this step to this step. So, so this becomes from this step, it is multiplied by 10,000. So you're going to multiply twice, and then again. So this is multiplied twice. Then you multiply twice, and that's why you see this is 2 square. Now from here to here, you'll see it is 10,000 2 raised to 3. It means because you're multiplying 2, 2, and one other 2. So the factor here you're multiplying is 2 is uh, multiplied 3 times, and that's why I see. And likewise, you can see you can go on like this. 4 will be 4, if it is 5. So this is the easy exponential function we can write, model the real world problem into exponential function and say 2 raised to n or x, whatever. So we can write this as population peak was 10,000 was what was the population in the beginning times 2 is the factor that multiplies n times. So that's all the lesson is about checking on how the sequence or this and the output they change exponentially. So all this. So let's go dive down. So all this is being done in the classroom, and I'll go straight away to the practice problem. So here are the 5, 6 typical problems I'm walking through that will help. So this is lesson 1 again, practice problem. This should assist you in preparation for the eliminate testing or also for the SAT, ACT question they ask. The first is what I'm supposed to do here is select all the sequences which are geometric. Now, what is the meaning of geometric sequence? Just a quick review. It should be remember the numbers that you have. Let's see, these are the numbers. There should be a same common factor every time you multiply the same number. Or remember, if this is like one number, one, let's say this, and this is A2, and A2 divided by A1 should be equal to the other ratio, A3 divided by A1. So every time you get a common ratio, that's what we want to know here, ratio. Or this is all, yeah, common ratio, which is R. So do you have that here? Let's check the first one. If you see the first one, uh, if I start with uh, make a table like this and draw this way, you can clearly see a 4 over 2 is 2, but 7 over 4 it's not 2. So the first one cannot be, uh, this is not a geometric sequence. What about the next one? Look at the sequence. If you see the sequence, 1/3 is every time you see it multiplies by if you see this, starting from first, 1/3 divided by 1 is 1/3, right? Then let's do this next one. 3 over 1. Oh, sorry, I made a mistake here. It should be, I made a mistake of the ratio. So the second problem, you can see, of course, you can common sense, you can see, hey, you multiply 3, and 3 times 1/3 is 3. So you already know the answer. So this is geometric sequence. But if you want to have to check how exactly to do, it's like 1 divided by 1/3, which is 1 times flip the denominator, it becomes 3, and answer is 3. That's the first. Next one is 3 divided by 1, the third term, and the second term is also 3. Next one, 9 divided by 3 is again 3. So that's why this is yes, that's correct. What about the next one? We see the next one, this thing increases by 2, like 1 plus 2. So this 1 plus 2 is 3, 3 plus 2 is 5, 5 plus, so this is not a geometric sequence because it doesn't grow by the same factor. Or you can say, hey, 3 over 1 is not same as 5 over 3. You can show. What about the next one, D? And you can say this multiplies 2 times 4 is 8. So you multiply 4, and 4 times 8 is 30. So it looks like this takes care. What about 4 times the first number? Do you get 2? And you can see it's 4 over 2 is 2. That's correct. So this is a geometric sequence. The next one, if you see here, if you take the ratio, what is there? It reduces, it slows down. Like how does it slow down? Let's take 200. 200, the second term divided by 1000 is, you can see this crosses out and you get 1/5. The third term divided by 200 also will give you 1/5. And 8 divided by 40 also is 1/5. So that's the common ratio. So this is common ratio. Or you can say it's also, later on we are going to call it decay factor because this is smaller than 1. And the last one is, you see, every time it decreases. That means 900 minus 100 is 899. So it goes on decreasing by 100. It doesn't multiply. So this becomes, this is yes, this is no. So you have to write in your own English words why you say this is not geometric sequence. So you don't have a, because it's like you can say, hey, this number is not same as, you can write like this also, but you can clearly see it grows by. So that's the first one. Okay, question number 3 is about, this is question number 3. So a blogger had 400 subscribers in the beginning. So if I can make a table, so that means in the beginning, month, and this is number of subscribers. I'll say S, and if this is M, I can put a variable SM. So in the beginning, that's in January, that's the first one, there were 400 subscribers, right? The number of subscribers has grown by a factor. So I already give you that factor, and you can see it's greater than 1. So that it is a growth factor because it's bigger, it means it increases. So every month, let's say 12, February is here, then the March, then the April, and likewise, you can write this. And you can see you multiply this, you multiply 1.5, and 1.5 if we multiply, it's 400, and you can see that 1.5 basically means what? It is 1 plus 0.5. It means it is 100% plus, it means the whole, and 50%. So that means 50% is the increase every month. So if this is 400, it will be 400 plus half of it. It becomes 600. And this is 600 plus half of 300. So every time you multiply by 1.5, that becomes 900. And again you multiply this, it becomes 1350. That's all they're asking you questions. I hope you make sense. We can also model this into a function and say uh, into which we are going to do later, because I want to focus only on uh, what is that called? Here I'm focusing mostly on practice problem. Of course, we can write backward and say, hey, in the January, but in the beginning you can say, hey, you can do this one. You'll have to divide by 400 and then uh, divide by 1.5, and then it means it is 400 times 2/3 like this. And you can get something in death. Oh, we can always, 3 doesn't divide 400, but we can always check and get a, we will see this very soon when we model the function. Okay, so let's go. Okay, so this is the third question, and let's check. The title says that the sequence, so there is a sequence. So let me do this. Uh, so n, and let's say this is a sequence a n 1, 2, 3, third term, fourth term, and likewise, and the numbers are 1. So every time it is 1. Each of these. So the title says it's not exponential because it does not change. Okay. So the question is, do we agree with the Tyler what he's saying that this is not exponential? Now, what does this mean is this exponential sequence? That's the question. And if it is yes or no, we have to give the reasoning. Okay, first thing is what's the difference between exponential sequence and geometric sequence? So now this sequence, if you see that a sequence is geometric if every time you have the same factor multiply. So there should be some number which is called a growth factor, decay factor here, or just a factor. Okay, so the ratio has to be the same. Otherwise, anything like second term divided by first term should be same as the third one divided by second one. So it has to be the same number multiply. So the question is, in this example, from here, what is the ratio? So let's see, this is A1 first term, this is the second term. So if I write A2 divided by A1, it is 1 over 1, which is 1, right? And you can see every time you can multiply 1. So this is a geometric sequence with a common ratio or ratio which is also called factor. So there is a factor. So this is a geometric sequence. The question is it an exponential sequence? Even the Tyler says they don't change. He's almost there, but there is one thing we could write here. When do we say that it is going to be an exponential? Now, exponential basically means there has to be some percent increase or decrease. You cannot. So if I want to go here, what is the let's say this one is b equals 1, right? So we can, and when we talk about exponential, it means b has to be equal to 1 plus r. So what is r stands for is percent increase or decrease, increase or decrease. In this example, when we can write this b equals 1 plus 0, it means it is 100% what is the beginning that you have, and 0% is nothing increase or decrease. So, and that's why, because there is no percent increase, this sequence is not exponential. That's what I'm trying. So this is not exponential because there is no percent increase or decrease. There's the b stays 1. So that's what that means. So the actual reasoning we could give is that there is no percent increase or decrease. So so we don't agree with Tyler's reasoning. So the actual reasoning is that. So hope that helps. Let's do problem number 4. Okay, the next question is about question number 4. In 2000, an invasive plant species covered 0.2% of an island. For the 5 years that followed, covered by the plant tripled every year. So you can pause this video for a moment and check if you can do it yourself. Okay, so let me go ahead and see, visualize what's happening. So I'll make a kind of a table. The table really helps. So as he said in 2000, that means I'm going to make this is 2000, this is 2001, 2002, 2003, and 2004 and 2005. So years since 2000, years since from 2000, right? So that means I'll put a zero here. So in the beginning, there was 0.2%. That means the question asked is, a student said that is about half of island's area was covered by the plant. Now, what is the meaning of half of island means 50% is covered. So that's what we have to check whether so do we agree with this statement? So what I'll do, this is 1 year, it's 2001, 2 years passed, 3 years passed, 4 years passed, and 5 years passed. So in the beginning, there was 0.2. So this is percentage coverage, percent, percent coverage, covered. I can even write this is T, and this could be percent coverage. We can use PT, you can model this, right? So it's like P, this is like P of 0 in the beginning, right? And so we have to, so in the problem it says every year it tripled. Now what is the meaning? Triple basically means you're multiplying by 3. So there's a growth factor of 3 from here to here. So, and then again from here to here, you multiply by 3, multiply by 3. You can do manually, of course. You just, students do, this is 0.6. Again multiply become 1.8. Again multiply 3 become 24. 2, 3, 1 are 355.4. Again multiply by 3, 3 4s are 12, 1 stays. 3 5s are 15, 16 point. And again you multiply. 3 2s are 6, 3 6 are 18, 1, 3 1 are 4, and 48. And you can clearly see this is almost 50, and 50 means almost 50%. So we already done the answer. But at the same time, I like to kind of go beyond this and see what is the meaning of that. Triple. So it's a triple. So we want to know what is the meaning of triple is 3, which is 1 plus 2. And what is this 1 plus 2? Means 100% what in the beginning that you have. And every time it is like you multiply 100 in the numerator and 100 in the denominator. So that's like 100% what was in the beginning. And then it is 200% percent increase. So this is percent increase every year. So hope that helps. So now we can model this and say, hey, PET in the beginning, because the formula is uh, so let me write the formula that we have for every each increase in the year is f of x is uh, e, uh, f of x is a is the first, then the growth vector b raised to x. So in this case, for every x changes from increases by one unit. That's the most important part. So if this works only when it is the input is 1 1 1, like that's how it is. So in the beginning you have 0.2. So that 0.2 will go right here. Okay, times, and now b that you have is this is b. This is b. So this is b. So that's b, which is 3, and raised to t. And you're done. That's so t equals is the number of years. So this is number of years since, that means you have to begin from 2000. 2000 the start year, right? So that's where it starts, and then you can figure out anytime. Okay, so that's all the question was, question number 4, and let's go to question number 5. I hope this video that I make assist you, helps you, so that not just because of your homework for the Algebra 2 IM practice problem every lesson that I do, but also this whole thing, similar questions are being asked. So these questions are asked for ACT and SAT. This and be also, if you want to do college placement testing, you get a whole idea of what is the how to build exponential function. So that's the main goal of mine. So every student should have this access in preparation for those tests. So this is question number 5 in the lesson 1. So a square picture. So if with the side length 30 centimeters is scaled by 60% on a photocopier. The copy is then scaled by 60% again. So what is the meaning of this? So I want you to read this question and see if you can figure out or visualize what's happening. So think over it for 1 minute maybe, and then you can watch the video again. Okay, so let Okay, so I will visualize this problem and write. Okay, in the beginning, it was this was the big one, then becomes smaller maybe, then again becomes smaller, again becomes smaller, again becomes smaller. So we want. So this is the first. This is the beginning, like when this is the original. Like let's put it like n copy of the original. This is the first copy, second copy, the third copy, and the fourth copy, right? So it is you're given a 30 centimeter is the side length, so the square, and then it is scaled. That means the B you're multiplying here. B is 60%, which is 60% means 0.6 because 60 divided by 100, right? So this is that decay factor. It means because this 0.6 is less than 1, so the B, which is less than 1, so it means it shrinks. So the copy, whatever this original copy shrinks by scale factor 0.6. So if you multiply, you get 18. You can check that with your calculator. Again, you multiply 18 times 0.6 and you get uh, 10. If you do 10.8, check that out. Again, you multiply 0.6 and you get 6.48. And again, you multiply 0.6, you will get 3.88, right, which is almost approximately equal to 4 centimeters, and you're done. But I'm going to go a little beyond that. So when the originally when this was the original and shrinks, okay, so B is 0.6. What that it is 60%. That means 60% of the original size stays. So how much is reducing by? So the question is, so this is 60% stays, and what is lost? So we can write 0.6, which is equal 1 minus 0.4, and that means it is 1 minus 40%, because the 1 means the whole, which is 100%, right? So from 100%, you take a 40%, 60% stays. This means this 40% is really getting reduced by 40%. So two things, 60% of the original size stays. So this is 60%, whatever that you see. But how much is lost is 40%. So this is a little beyond the thing. We can model this also into a exponential function that we know this. This is when x starts with 0, 1, so increment of this, right? Not fractionally increases, but just 1 unit. And the beginning was, we can see the size. I can put S of n is number of copies. And we can see in the beginning it was 30 centimeter and 0.6 is the growth factor or decay factor here because it's getting reduced, raised to n, and you're done. So that's how it is. Okay, let's go to the last one. The question number 6 is about unit 3, lesson 1, I think. So this just kind of a review can help us for the SAT, ACT. Geometric sequence is given like this. And explain how would you calculate the value of the 50th term. Now remember, you can easily make a table like this way, and let's call this as an. So sometimes we use an, or sometimes we use an. It means one and the same. 1, 2, 3, 4, 5, and likewise. So the beginning, the first one is 5, first 15, and then so you can see what multiplies is 3. So they already said it's a geometric sequence, and you can see 15 divided by 5 is the factor, that is 3. So each time you multiply 3, right? 45. So we can't just go on. Of course, this few of them we know we can do, but we want the one which is 50s. Is there a formula for that? Now, whenever the sequence the starts with 1, see the n, if it starts with 1, the an, the nth term is the first one, the very first one, a1 times the ratio. So this is the ratio, right? So this is the ratio, r raised to n minus 1. So that where n is greater than equal to 1. See? So we can write a, and in this example, a1 is 5, that's a1, and times 3 raised to n minus 1. And you can, so this is for n greater than or equal to, or you could also, if you can change this, like, if I want to go backwards, let's say we want to write one more using exponential function type. Instead of this, I'll make a 0 here. So if I multiply 3, so going backwards, oh, uh, anyway. So what I'm saying is, if you go backwards, this will be divided by 3. So this will be 5 by 3. That means when 0, so let's wipe this off. It looks too shabby here. Make a table again. So this is 0. Okay. Now that means if I go backward, it's going to be 5 by 3. So this is n, this is an. Or I can call it as x and f of x. Like we can create a function type. And in this case, it will be f of x equals, or you can keep this also and say, hey, now it's going to be different. And write an equals whatever the first, here it is 5 by 3 and times 3 raised to 3 raised to n. See how it changes? So this is n minus 1 because you are beginning from 1, but now I'm starting from 0. So this will be the first term, and that's like a exponential function with the growth with the vector 3. Thank you. So with this, okay, there's one more problem last. I'll do quickly maybe. Okay, so this is the last one. Okay, that's it. Okay, so they give you what is this equivalent to? Now 9 raised to 4 can be written as 9, 9, 9, and one more 9, which is also could be written as 3, 3, 3, 3, 3, 3, 3, 3, because this will give you this one, this will give you this. So wait now. So there is 3 raised to 8 of them, or you can also write 9 square, like 9 square and 9 square. So here it is. It's also 3 raised to 8 and also 3 raised to 4 because this is 3 raised to 4 and that is 3 raised to 4. So I hope that takes care. So thank you. And so as I said, if this in the link, when you open this link and once you are done with all this practice problem, make sure you can click on the like button and also share it with your friends on maybe to all your friends or all these resources to help them to assist. So I want this to go to many students to get a lot of resources. So please do like and also share and also put some comment. What is that you learned from here? What are 2 things that you learned? So that would be, I would appreciate your comments that can help. Thank you so much.